I'm David Moseley, and I'm going to give a presentation on maximizing soybean yield while minimizing risk across Louisiana. The pictures you see here on the far left is just a healthy field of soybean, very green, growing vegetatively very well, and with hopefully leading to high yields. That's, of course, what we want. You can see in the second picture some soybean this year that was already up, maybe the V2 growth stage, and there was a freeze on March 17th that killed the tissue. Thankfully that soybean was able to grow back, but that's some things we have to consider is planting too early and getting a freeze. And then you see the pictures after that, some soybean that was just about mature, and we had too much rain too many days in a row, and the soybean basically was ruined, couldn't really be sold for very much money at all. And that happened in 2022, and it was with April planting dates. If it was planted in May, they weren't mature yet, and they weren't run by the rain. So we can see, different planting dates can cause, well, there can be different problems based on the planting date. So talking about planting dates, we see in just looking at the trend from 1968 to 2000, the farmers in Louisiana planted from May to June. But from 2000 to the present, they're planting in April to May. And this is called the early soybean production system, where soybeans are planted earlier. But first I want to say that planting date can affect yield with soybean. It's different temperatures and different day lengths. Both temperature and day length will affect the amount of time for soybeans to begin flowering, and also just the growth rate, especially after it flowers, mostly affected by temperature, but before it flowers, the day length and the temperature will affect soybeans on the time to flower. In general, soybeans will flower when there's a certain when the length of nighttime, the dark hours, gets short enough, or the day gets long enough for that particular maturity group to flower. Talking about maturity groups, in the United States, there are maturity groups of 0 to 9, with the 0 maturity groups for the more northern states and the maturity group 9 for the most southern states. And it just goes in order. Like 1 would be more northern, then go south 2, then go south 3. And in Louisiana, from approximately 1968 to 2000, the farmers grew maturity groups 5 to 8. But once again, from 2000 to present, the farmers are planting maturity groups 3 to 5 mostly, and they're planting in April to May. So this is called the early soybean production system, which compared to the full soybean production system planted in May or June with maturity groups 5 to 8, they're planting maturity groups 3 to 5 in April to May. The benefits of early planting and maturity group, we can see basically the soybean plants escape stresses, heat, drought, disease, insects. Most of those things move in later in the summer into July, August, when the plants could be almost done by then if they're planted early enough with the earlier maturity groups. So we do see possible higher yield and less production cost if we're planting earlier with earlier maturity groups. Just looking at the trends so on the x-axis you have the year, and the y-axis you have the date that 50% of the crop was planted in Louisiana. In 1980, you see 50% of the crop was planted by about June 1st, and in 2026, the 50% of the 50% of the crop was planted in mid-April, or really, about mid-April. But this year was really fast, where 93% of the crop was planted by May 3rd. So just really getting very, very fast in the planting. We can see the linear trend since 1980 was about 0.9 days earlier per year. And looking at the x-axis on this graph, we see the year on the x-axis and yield on the y-axis. And we can see that in 1980, the yield was a little less than 1,500 kilograms per hectare. In 2025, about 3,500 kilograms per hectare. So we don't say earlier planting dates is the cause of the higher yield trend, but we say it's definitely associated with the higher yield trend with a linear trend about 50.3 kilograms per year. So looking at those two things together, we have on the x-axis we have the date where 50% of the crop was planted, and yield on the left side, the y-axis, and then the color code would be for the year. So we see just starting about, say we see April 15th on the x-axis, we get about 3,500 kilograms per hectare. June 15th, when the 50% of the crop would have been planted, we are about 1,500 kilograms per hectare. And then you can see the year. So about April 15th at the 3,500 kilograms per hectare was 2025. And all those yellow and green dots are in more recent years. And then when you get to the darker dots, that's more farther back in history. So farther back in history, they're planting their crop later and getting lower yields. So there's a journal article published in 2024, Louisiana soybean planting dates and maturity groups maximize yield potential and decrease risk in Northeast, Central, and Southwest Louisiana regions. And just to show the different regions, in the Northeast Louisiana region, the quadratic curve was significant, and the quadratic curve was more significant than a linear curve. And looking at it, we didn't want to just see the most optimum date because it's not possible for farmers to plant on one date. So I wanted to see what was 99% of yield potential of that optimum date. And we can see there would be a planting window from March 28th to April 20th to get 99% of the optimum yield. So that gives the farmers a little bit of a window to get planted and have almost full yield potential. For the Northeast, I didn't have enough data to separate out maturity group sections, but for Central I did. So the quadratic curve once again was the most significant curve, and we can see that we have the optimum date, but we also have an early date and a late date for each maturity group section to get 99% of the optimum yield potential. And we see that very similar to the northern region, the 4.5 to 4.7 and a 4.8 to 4.9, the planting date window was about the same. March 26th or March 27th to April 19th to April 20th. So acting right at the same as the Northeast region. And also the data of the Northeast region would have been mostly 4.5, maturity groups 4.5 to 4.9 anyway. That's what mostly they grow in the Northeast region. In the Central and Southern region, they'll grow more of the 5 or later, or in some cases the 3 to 4.4. We see for the Southwest region, the dates are shifted later, really more to what they used to do before the year 2000 when the early soybean production system started. So we see that about early to mid-May would be the early date into June for planting dates for the Southwest. So the Central and the Northern region, they act in planting dates closer to Arkansas and Mississippi and then what we call the Mid-South. But the Southwest Louisiana, a little bit farther south, doesn't really show the same trend. They show a little bit later, and even will show the maturity groups 5 or later can have higher yields in the Southwest region. So we look at the quadratic curve for the Northeast Louisiana region. We have the date planted on the x-axis and the yield on the y-axis, and we can see that what's in red would be before the actual date, so projected data. And we see the triangle shows the most optimum date is April 7th. And that's also the earliest data that we had for the Northeast region. And we can see that on the April 7th date, we have a lot of downward yield risk if we plant a lot of data points shows that we yielded less than the curve. So some risk there for for April 7th planting, which is really driving the projection to go down as you plant earlier than April 7th. And we also see we plant late, past June 15th, we have a lot of downward yield risk as well, planting late. So looking at the Central Louisiana region, I was able to break it up by maturity group section with 4.5 to 4.7, and the top blue line being the highest yield, and then the 4.8 to 4.9 being the second highest yield. And then we also have, before March 15th, the projection as it was earlier than the actual data, and then after June 15th, projected using the quadratic curve. We can see where the symbols are. We have the most optimum date, and then the white circles being the 99% window. You can plant within that window to get 99% of the optimum, the most highest yield projection. We can see when we plant March 15th, there is a lot of downward yield risk. So, and it's not even the highest yield possible. So you want to get closer to this 99% window. There's less downward yield risk, but we plant later. Not really much. Doesn't increase much on the downward yield risk as you get later, but certainly the yield projection goes down. So looking at the Southwest Louisiana region, so you can see that the planting dates are shifted later, and the brown line would be maturity group 4.5 to 6, so that would be the higher yield. So you really the maturity groups are later and the planting dates later as you go to the Southwest region. So we saw previously we want to plant at the right date, but also we have a window to plant in, about a month's window to get 99% of your yield potential. And we can see we want to plant the best we can, plant a little bit of a staggered planting, because we plant everything at once, we run into some risk. So here I have a March 3rd planting date, and the soybean came up to about the V1 growth stage, and we had a freeze on March 17. And you can see on the left picture, the trifoliates and the unifoliates were seen damaged on that next day, and then even they got burned down to the ground in some cases after the freeze. Now they did happen to come back, which is kind of surprising, and a lot of corn plants in the state did not come back, but the soybean were able to come back on auxiliary branches, which is kind of backwards what we project. But I've seen before when a freeze hits, the soybean did not come back. So there is a risk you try to plant everything too early, and then you get a freeze risk. Also, last year we planted everything planted in, well, I'll say this. So you see what's circled here on the progress of planting. The solid brown line is 2025 planting progress, and the dashed line would be from 2024, and the dotted line from the 5-year average. You can see that the planting rate was a little bit faster than the 2024 planting rate. However, when we look at blooming, the progress to blooming became much faster than 2024. And there was actually a lot of complaints about this, a lot of comments that the plants were flowering too fast. They were flowering at about the V3 growth stage instead of V5, the more normal time for these indeterminate varieties. And so early flowering causes a few problems. One, you have less nodes at flowering and potential less yield, but also a lot of herbicides. The time that cuts off when you can apply a herbicide is at R1, so when it starts blooming. So about 10 days is V3 to V5 is about 10 days early. So that really hurt people's herbicide programs, flowering early. So everything planted in March and maybe even early April seemed to flower a little too early last year in 2025. We're kind of looking at why that might have been. This graph has date on the x-axis and solar radiation on the y-axis. And all the blue dots are rain events. And the orange lines are solar radiation, and the red circles is how much rain, a bigger circle for more rain. You can see just many days in a row, there's a rain event. A lot of times it's a lot of rain. So it really caused the solar radiation to go down, and less light or more dark hours can cause soybeans to flower early. So the 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 environment might have caused plants to flower early, and this was on soybeans that were planted earlier in the year. So it caused some risk to plant early, even though that's where we get most of our yield. Also consider, so we have month on the x-axis and yield on the y-axis, and we have the planting dates, or this is a planting date study, a 3-year average, and we have planting dates 1 to planting date 6, and we can see planting date 2 at about a mid-April planting date. That's where we can get most our highest yield. But when you look at the canopy coverage at V4, well, when you look at the canopy coverage at V4, the later planting date, the third planting date had the highest yield, had the highest canopy coverage at V4. So it is true that you can have higher yield with a little bit earlier planting date, but your canopy coverage at R4 is higher when there's a little bit warmer temperature. So that's something to consider when you're planting. Are you having the right mixture of planting date to get the yield potential, but also to get the canopy coverage you want for weed control? So on this slide, we have planting dates and also maturity group to minimize risk. And I want to show you that disease pressure based on planting date. So on the left picture on the left side, we have a healthy canopy, and it was healthy soybean was planted in May. And on the right side, we had soybean, the same variety, side by side, planted in April. So we do know that April is where we get most of our yield. But last year, the plants planted in April were hit by Cercospora leaf blight when planted in April, but in May really did not get hit by Cercospora leaf blight. And on the picture on the right, you can see really good looking pods with seed inside. In the picture right from there, you have pods, but there's no seed inside. So the pods with no seed inside was planted in April with the canopy looking not as green, and the pods that have seed inside were planted in May in this canopy that looks better. So in this case, planted in April, same variety, got hit with Cercospora. Planted in May, did not get hit with Cercospora. So this is a risk when you plant everything at one time. You run the risk of getting the disease hit or a freeze hit, and would really can cause your yield to decrease, or in this case was almost zero. We're so hit by Cercospora leaf blight. And also in 2022, we had a lot of rain in August, and so everything planted in April just about across most of the state looked like this, because we had several days of rain in a row right when they matured. Pods were splitting up open, the seeds inside were weathered, seeds were germinating in the pod. When you split them open, just brown, just really weathered on the outside, very weathered. In this case, the soybean farmer actually had to sell for a much discounted rate, all the way from maybe $12 a bushel to $4 a bushel, just salvage beans. And we had that across maybe even $500 million of loss in 2022. And everything planted in May or April got hit like this, and planted in May, really, they weren't mature enough. They weren't yet mature, so they weren't run by the rain events. So there is, once again, we know that planting in April give you the highest yield, but if you plant everything at the same day or close to the same day, you run into a risk of big weather events happening or disease. So just showing the graph on what happens, when you plant at certain times. You have the estimated R7 date, so the beginning maturity on the x-axis and the maturity group section on the y-axis. And so we have expected R7 timing by maturity group section and planting date. So if you the color code on the key on the right, planting date range. So the blue dots would be planted in March 20th to March 28th. And you can see if you plant at 3.8 to 4.4, then you get the R7 a little past June 15th, but almost August 1st for 4.5 to 4.9. And then it fluctuates a little bit for the 5.0 to 5.4, but then 5.5 to 5.6 would be a little past the 4.5 to 4.9. So you can see, in general, if you plant earlier in an earlier maturity group, you're going to get to R7 faster than you do with a later maturity group or a later planting date. So one recommendation is you can plant, if you want to plant everything at one time or within a small window, then you can change up your maturity group sections and at least spread out some of your risk, especially for heavy rains, all within 3 or 4 days. So if your plants aren't maturing within the same 3 to 4 days, then you don't run the same risk of a 3 to 4 day rainfall. And also, you change your planting date, you definitely can space out your timing. And this is very important for Louisiana because just the last week, look, just the last 2 months, we've had 28 or maybe even up to 30 days of rain in the last 2 months. So on average, that's every other day it's rained. And in the last week or so, it rained every day. And 2 days ago or so, they had in some areas 10 to 20 inches of rain in just one day. So in Louisiana, we can have a tremendous amount of rain all at once, and it is good to space out your planting so your risk is spaced out a little bit. Here's the reference to the journal article that I mentioned, and I want to thank you for your time.